Hey y'all, today we're going to do connective tissues, and this might be a long one, so get comfortable and get your notes out, and we are going to go through the 10 types of connective tissue. The first two connective tissues, or three connective tissues that we're going to do, are classified as loose connective tissue, and what that means is that the fibers and the cells within the connective tissue are not tightly packed. They're kind of sporadic, they're kind of sparse, they're not real close together, and there's no real pattern to their arrangement. Mixed in with the fibers are going to be cells, and different cell types will be in different tissues. But the first two that we're going to talk about are first three, are loose connective tissues, and specifically the first one is called loose areolar connective tissue. Now, I might just call it areolar connective tissue, but some people will call it loose areolar connective tissue. The loose is just kind of assumed whenever you look at a picture of it. So let's look at this picture and figure out what parts and pieces are in this connective tissue. The first thing we're going to notice is that there are two fiber types that are obvious. The first one is elastic fiber. Remember that elastic fiber is stretchy, it is thin, and it stains purple. Whereas here we have a collagen fiber or a collagenous fiber that is thicker. It has a lot of tensile strength, and it will stain pink in comparison to the elastic fiber. We also have a few cells that are obvious. Here's one, here's another one, here's another one, here's another one. And then this is a big cell, huge cell in comparison to this one. The smaller cell is a fibroblast, and it makes fibers. It'll either make the elastic fiber or make the collagen fiber. And the bigger cell here is a mast cell. And a mast cell is going to release heparin and histamine in response to an immune response or immune reaction in the body or an inflammatory reaction in the body. Here's another image here, a little bit darker stain, but you can still look at the difference in the size of the fibers. The skinny one here would be an elastic fiber. The thicker one here would be a collagenous fiber. These darker areas that you see are nuclei of fibroblast, and then we have a mast cell that is spreading its contents out into the area, which again are histamine and heparin. Histamine is going to cause itchiness, and heparin is going to cause blood thinning in the body. All right, so let's look at the information about areolar connective tissue. It is a bubble wrap for the body, and it will wrap and cushion organs, protect organs. It'll hold tissue fluid if there is an inflammatory response. Tissue fluid is going to cause swelling, and so the change in size that you notice when an area is swollen is due to that tissue fluid. It's also going to contain macrophages, which are a type of white blood cell that will engulf and destroy bacteria if we need it to. The cells within this connective tissue are fibroblasts, which we looked at in the picture, mast cells, macrophages, and other white blood cells. So it kind of has everything. They say this is like the kitchen sink of connective tissue because it's got bits and pieces of all kinds of cells and a lot of fiber types. The matrix, remember that matrix is the part of connective tissue that is non-cellular. It's everything but the cells, and it's going to be gel with collagenous fibers, elastic fibers, and a few reticular fibers. You may not see the reticular fibers, but they're there. They're just not very tightly packed, which again is why this is a loose connective tissue. The location would be where we would have this tissue, which is underneath your epithelial tissue. This is what makes up the tissue under the basement membrane of your epithelial tissue. It's found between organs and under the skin, so just a tiny little layer underneath the stratified squamous epithelium of your skin. The next tissue we're going to do is adipose tissue, and adipose tissue is fat tissue. This is what we would classify as any kind of fat in the body, whether that's right under the skin or within a cavity. Fat tissue is adipose tissue. Has a fairly white or creamy colored appearance to it. These are the cells. So they are huge, and they appear to be nothing but just big blobs. And that white coloration is coming from a lipid droplet within the cell that will fill the volume of the cell. So if I were to outline one cell here, it's going to have the majority of the volume of the cell filled with that lipid droplet, and the nucleus is going to get pushed to the side. So in most of these adipocytes that you see are these fat cells. So each one of these is an adipocyte. The nucleus is either invisible because it's so pushed to the side, or it's barely visible and will definitely be on the periphery, excuse me, of the adipocyte. So this area, this white area here, is called a liposome. And the liposome is the lipid droplet, the white coloration that you see inside this cell. And again, the nucleus is here, and the black outline that I've done is the cell membrane. We look at this picture, same idea. White here is a liposome. The nucleus would be here, and then the black would be the cell membrane that I've drawn in. Here's another image. Just be careful with this, because if you're not paying really close attention and you mix this together with epithelial tissue, it can appear like simple squamous, because you might think that this could be simple squamous cells lined up in an air sac of a lung. It's not, okay? So be careful and look closely at the structure of the cell membrane. Okay, the function of adipose tissue is protection. It will protect organs. Sometimes you have a little fat capsule around organs to give it a little bit extra cushion and insulation. It is also used for insulation to help keep us warm, and then storage for lipids. So if we have excess lipids, we can store it up in the fat tissue. If we need lipids, then we can go to that fat tissue and burn it to make ATP. The cells within adipose tissue are adipocytes. Remember that translates directly to fat cell. And the fat droplets or lipid droplets within those cells are called liposomes. That will cause the nucleus to be pushed to the side. The matrix, which is everything but the cells, is going to be the same as loose areolar connective tissue. So we'll still have some collagenous fibers, some reticular fibers, some elastic fibers, but you can't see it. Okay, because the adipocytes take up most of the tissue, the fibers are invisible. The fibers are not concentrated enough to be visible within that tissue picture. Where do you have fat tissue? Under the skin. So that's what I call like pinchable fat. You can see that under the skin. You can feel that under the skin. Around your kidneys, there's a little fat bubble or fat capsule around the kidney to protect it. Behind your eyeballs, there's also a little fat cup that will sit inside of the orbit of your eye to help protect it. Around your heart, there is a little balance of just enough fat tissue, but not too much fat tissue to help insulate the cardiac muscle, and then the breast. And so most of your breast, especially in a female, is glandular tissue and adipose tissue. The third tissue that we're going to look at is reticular connective tissue, and it's still classified as a loose connective tissue. It is composed of a lot of reticular fibers, and those reticular fibers, again, are like a loofah, and they're going to hold the cells in place. They're going to form like their own little skeleton, or the reticular fibers are going to form their own skeleton, and all of the cells are going to get caught up in that netting. The cells within reticular connective tissue are white blood cells and lymphocytes. And lymphocytes are going to help form antibodies that will help prevent you and help you in the immune system so that you do not get sick. When we look at reticular connective tissue, it's going to look like all of the pink background that you see should be gel or should be some kind of ground substance, but that's actually cells. So that's how concentrated and tightly packed the cells are in reticular connective tissue. Depending on the stain, it might have this grayish purple color, and you can see here the cells are close together, and each one of these round cells is a lymphocyte Each one of these black stringy things that you see here or on the other one is a reticular fiber. Okay, so the function of reticular connective tissue is to form a soft skeleton. You've got to have a skeleton to hold all of the cells. And that skeleton is also going to help serve as a filter. Okay, think about it as like a coffee filter that's keeping the coffee grains on one side and the coffee on the other, or the water on the other. The name for that soft skeleton is a stroma. So the stroma is the loofah that we looked at in class. The cells are going to be fibroblasts. You got to have a way to make the reticular fibers, and so those are done by fibroblast. Phagocytic cells, so if something were to get inside of the liver or the lymph node or the spleen where this is found, you have a way to break it down by using a macrophage, which, remember, translates to big eaters. And you also have lymphocytes, and lymphocytes are going to be the most visible cell in reticular connective tissue. The matrix is reticular fibers in a gel. Okay, it is nothing but reticular fibers forming that soft skeleton that's going to hold all of the cellular component in place. And then you have this in your liver, your lymph node, your spleen, and bone marrow. Okay, in all of these areas of the body, there's some oomph to those tissues. The liver's got some structure to it, and your spleen has the same texture or appearance. So do lymph nodes. They're just much smaller. And so in all of those areas, you've got that internal scaffolding, that internal structure that's going to help hold things in place. And then also in those areas, you're going to have some kind of filtration function, whether we're breaking down toxins, whether we're breaking down old red blood cells. Whatever we're doing in those organs, we are using filtration as the main function. Okay, the next two are going to be your dense connective tissues, meaning that instead of the fibers being sporadic and just kind of wherever they want to go, they're going to be tightly packed. And in dense tells me that the fibers are tightly packed. Regular tells me that they have a regular pattern. And the fiber type that will tightly pack or condense with each other in this tissue are collagenous fibers. And those collagenous fibers are going to arrange themselves parallel to one another, and that's going to cause a very strong rope-like tissue called dense regular connective tissue. Because it has a lot of fibers, you have to have something to make the fibers. So you also have to squeeze in fibroblasts wherever they can fit. And so in between these sandwiched collagenous fibers, you will have fibroblasts, but they may be very small and they may be very flattened in this tissue. If we look at the picture here with the A and B, it just looks like nothing. Okay, it looks like clouds or a lot of white background, but that's the fiber. So remember, collagenous fibers are white in the body. And so these, I'm going to outline, let me draw in where the collagenous fibers are. So this is one, and it can have a wave to it. But the point is that they run pretty close together, and they run in fairly linear shape down the tissue. A is a fibroblast. So they're tiny. I mean, they just get flattened and smushed in between these collagenous fibers. Why do I know they're fibroblasts? Because I have to make a fiber, and that's the purpose of those cells. Here's another one. Remember, collagenous fibers stain pink, and so you can see a collagenous fiber running parallel here, or running linear here, and then one running parallel to it. And the fibroblasts are going to get flattened in between the two in between the two fibers here. Here's one fibroblast, and then here's another. You can see they're stained purple. Okay. Dense regular connective tissue is going to be good for binding things together, good for connecting two tissues or two things in the body together. You got to have a lot of fibroblasts, but you may not be able to see them. And within the matrix, you will have collagenous fibers and maybe a little bit of elastic fibers, but the one that's most visible is going to be the collagenous fibers. And you'll have this in your tendons, your ligaments, and the sclera of your eyeball. Okay, so tendons are going to connect muscle to bone. Ligaments are going to connect bone to bone. And the sclera of your eye is the white of your eye. The reason that it's white is because it's collagenous fibers. And so instead of it being in a rope like a tendon or a ligament, it's just going to get rolled into a sphere. The next one, we're going to take the same idea as dense regular, but we're just going to change the arrangement of the collagenous fibers, and we're going to create dense irregular versus dense regular. In this picture, it looks again like the background is pink and that it's just going to be a gel, but it's the collagen fibers, and they are so close together that it just looks as if there's nothing in the background. The collagenous fibers are going to be tightly packed, but they're going to have an irregular arrangement. And because they have a swirly or less parallel pattern to them, they can withstand tension in many directions. And because they have collagenous fibers, we got to have fibroblasts to make them. And so all the black dots that you see here, purple dots, are going to be the nuclei of those fibroblasts. Okay, dense irregular can withstand tension in many directions because of the arrangement of the collagenous fibers. And it's also going to be found in areas where you need structural strength, like under the skin. We've got to have some flexibility, but we've also got to have some structure to the skin. We also have this around the joints of the body, so anywhere where two bones come together, specifically like knee bones or shoulder bones or elbow bones or finger bones, where those two bones come together, there's going to be a little capsule or a little sheath or a little covering of dense irregular connective tissue that just gives a little bit more stability around those two bones to help hold them in place or in alignment. It's also found in your digestive tract, but I would rather you focus on the dermis of the skin, which is kind of the middle layer of your skin, and then the joint capsules, which are going to be around the bones where they come together. All right, so that's the first 5 connective tissues. We're going to stop here, and then I'm going to do a separate video for the second 5 connective tissues.